Dear students, I welcome you all to this problem solution series in digital electronics. I am solving the problems from the book Digital Design by Maurice Mano and Michael Sileti. So in this video, I am solving the problem number 6.2 from the chapter number 6. The problem is include a synchronous clear input in the register of figure 6.2. This figure is from inside the chapter. This synchronous clear input means this clear will be applied to all the flip-flops at the same time. We will see while modifying the design. The next is the modified register will have a parallel load capability and synchronous clear capability. That is, the load will be given as well as the synchronous clear will be given parallelly. The register is cleared synchronously when the clock goes through a positive transition. Whenever we have a clock positive or rising edge, then we will have the transition, and the clear input is equal to 1. Now this is the figure 6.2. This is from inside of the chapter. This is figure 6.2. Here we have load. This load is given parallelly to all these flip-flops. These are the D flip-flops and these are the outputs and these are the clock inputs. Whenever this clock is equal to 1, and we have to introduce a synchronous clear input. So whenever both the clear and the clock is equal to 1, this circuit will have the cleared output. That means all the output ports will have 0 values. Now let us see for the load and clear. So load, then we have clear, next we have capital D and operation. We will see the operation of this circuit. So let us make this table. Here we assume that load has priority over clear. So for this load and clear, we will have 4 types of combination: 0 0 0 1, okay, 1 0 1 1. So for 0 0, that means load is 0 and clear is also 0. The output will be no change. That means the previous output will be the D input. That means here we'll have this previous output A0. This will become this D input. Okay, so here we'll have A0, suppose, for the first flip flop. Similarly for second flip flop it will be A1, and similarly for this third flip flop this will be this D will be A2. Okay, and the fourth flip flop will have this D will be equal to A3. Okay, so I am writing for the first flip flop. Okay, whenever we have load is 0, that means whenever there is no load, okay, and the clear is 1. Now what we have to do, when clear we have 1 value, when the clear input is equal to 1, the outputs will be cleared. Okay, so whenever this clear is 1 and the load is 0, so here we'll have 0 output. So this previous was no change, and here we'll have clear to 0. Then we have load is 1 and clear is 0. So we need not to clear here because it is 0. So load is 1. So this A0 will be equal to this input I0. So here we'll have I0. Okay, so this will be load input. Now here we can see that for the last case, when the load is 1 and the clear is 1, we will have to actually, for clear is equal to 1, we have to clear the output. But here we have assumed that the load has priority over clear. That means whenever load is 1, the irrespective of this clear input, this D input will be equal to I0. So it is load input. It is the same. That means whenever we have load is equal to 1, and irrespective of this clear, that is don't care condition for clear, we will have this I0 equal to D. Now let us draw this clear line. So we will apply this clear to this upper AND gates. This clear will be applied through a NOT gate, okay, through an inverter, and it will be applied to this upper AND gate. Okay, so this will be again connected to this second flip flop as well. Okay, so connect. So here we have to connect to this upper AND gate. Okay, so whenever we have this clear is equal to 1, that means here we'll have 0. That means all this AND gate output will be 0 here. Okay, so here we'll have disconnected. For the third flip flop also we have to connect this clear to this upper AND gate. Okay, and for the fourth one also we'll have to connect this to this upper AND gate. So in this way, when this clear is equal to 1, that means here after this inverter will have 0 here. That means we are applying 0 to all of these upper AND gates. It means irrespective of the other values, this upper AND gate will give 0 value. Now it depends on the load signal. So whenever we'll have load is equal to 1, so irrespective of this clear, that means you can see here, if it is load is 1, here we'll have 0 and here we'll have 1 again, because we have two inverter here. Okay, so after this second inverter we'll have 1 here again. Okay, so apply to all these lower AND gates. Therefore it will have 1 input if this I0 is 1. Here also you will have 1 input if this I1 is 1, and so on. So here we have this OR gate. So if any one of this input is 1, so this output or this D input will be 1. So this is the solution of the problem number 6.2. Thank you for watching. If you have any question, please put it in the comment section below. Also like, share and subscribe to my channel. Thank you.